Today's lesson, we're going to talk about exponential growth and decay models. We discussed the other day in class about how to make money grow, so you could become a millionaire. Well, what today we're going to do is we're going to look at how to take some basic exponential growth formulas and do the calculations to see if we can make some of those amounts of money happen. So a couple things we have to talk about. We have to talk about compound interest. We need to know what interest is. We need to know what principal is. Principal is your starting amount. That's how much you start with. Interest is the amount of free money that you can get, or if it's a loan, it's how much you pay the bank, which is free money for the bank. We have 4 different formulas we're going to talk about today. So you can read through that this paragraph. Remember, interest is how much money you pay or get paid for doing nothing, just loaning money. Principal is how much you start with. Compounding just means how many times the interest is going to get calculated. So like a basic formula would be your interest is calculated once a year. It could be compounded monthly, daily, quarterly, continuously, and we'll talk about that as well. So these are different. These are the different vocab words you'll see. So let's look at what the formulas look like. So exponential equations. So we have 4 of them that we're going to talk about. The first one is A equals P parentheses 1 plus R parentheses raised to the T. A is your final amount. Notice up here at the top of the page above the box it says A is final amount, P is the principal or the starting amount. 1 is just 100% or 1. Plus R is your rate as a decimal. Make sure you convert it to a decimal, not a percentage. And then T is time in years. Eventually, we'll talk about what N is when we get down to the formula. So this is a growth model. So anytime you're going to be growing, you'll have a plus sign right here. Okay. The next one is a decay model. And that's when it's going to be a minus. You're losing value. This one is going to be compound interest, means you're going to be compounding interest more than one time per year. And then this one is continuous. And we'll talk about what E is here in a little bit. E is just a number. It's 2.71828 something, blah, 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 goes on forever. It's similar to pi. Pi is a representation of 3.14159, so on and so forth. E is called the natural number, and it is 2.71828, and it goes on forever without repetition, just like pi does. So these are the formulas we're going to talk about today. So let's look at some examples. It says Mr. Hughes invests $25,000 each year from the age of 18 till 65. How much money will he have if the interest rate is 10%? So that is going to be a growth model. We're going to take $2,500, and we're not going to do each year. I typed that wrong. We're just going to take $2,500 and we're going to put it in the bank or into an account, and we're going to let it increase by 10% every year. So that would be the growth model. It would be this one right here. The money is going to be getting larger. So we need to figure out what variables we know. A is the ending amount. Do I know how much money that is going to be at the end? We do not, so we put A. P is the principal. How much money did we start with? We started with $2,500. So I put that in there. 1 is just 1, plus R is the interest rate. The interest rate is 10%, but we need to convert that to a decimal. So you move the decimal point 2 places to the left. So it's going to be 0.10 raised to the T. So you actually need to do figure out the time frame, 18 to 65. You need to calculate that. So you would do 65 minus 18, which is 47 years. So then you would do 47 years. So then what you do is you're going to use a calculator. So you're going to have a calculator. So you're going to pull that up here to the side. And I'm going to use the calculator. And you would just type it into the calculator. I don't know if you guys are going to be able to see this or not. But I'm going to use the calculator. So I do 2,500 in the calculator. And then I would do parentheses 1 plus 0.1. Or you can do 0. Close the parentheses, caret or raised to the 47th power. You type it in exactly the way it looks on the right-hand side of the equation, and you hit enter. And what happens is I get the amount of $220,000, $220,493.71. So I would get $220,493, and I believe it was 71 cents. The calculator just disappeared. And that's all you do. So what I did was I took $2,500, I put it into an account, and I let it sit there for 47 years, and it turned into $220,000. It's pretty nice to be able to do. So let's look at another one. It says a computer engineer is hired for salary of $28,000. If she gets a 5% raise each year, after how many years will she be making $50,000 or more? Set up the equation, but do not solve. We're not going to be able to solve for time right now. We will eventually. So this is a growth model. So it's A equals P parentheses 1 plus R raised to the T. We can't solve for T yet because we don't have the content knowledge yet. We will. That will be coming up later. So how much did we start with? We started with 28,000. And how much did we end with? We want to know when she's going to be making $50,000. So we put $50,000 as our ending amount. It would be 1 plus our raise is 5% per year. Move the decimal 2 places. Notice it's 0.05. You move the decimal 1, 2, and you add a 0 in there. And then it's raised to the T. We don't have the knowledge yet to figure out T. We will. So it just says set up the equation, but do not solve. There it is. We set up the equation. We didn't solve it. That's all you need to do. Okay. Here it says the savings amount grows from $3,000 to $3,450.78 in 12 years. What is the interest rate? So we know the ending amount, which is $3,450.78. We started with $3,000. Parentheses 1 plus. We don't know the interest rate, but we do know the time. So what you do is you solve this equation. I'm looking for R. So I have to get this parenthesis by itself. So the first thing I'm going to do is I'm going to divide the 3,000 over because it's multiplication. So with the calculator, I'm going to do that. So I have $3,450.78 divided by 3,000. And I hit enter and I get 1.15. 1.15026. 1.15026 equals parentheses 1 plus R raised to the 12th power. Now, how do I get rid of that 12th power? The opposite of that would be to take the 12th root. So we take the 12th root of the left side. The right side is going to be 1 plus R because the exponent of 12 and the root of 12 are going to go away. How do I do that on the left side? I take the 12th root. So with the calculator, you're going to hit 12, math, and then it's the 5th one down, so you hit the number 5, and then you type in 1.15026. And you hit enter, and you get 1.1011. 1.1011. 011, I believe. Check that. Yeah, 1.0117. Subtract the 1 over, and you get R equals 0.0117, and then we want to turn that back into a parenthesis, percentage. So we would move the decimal place 1, 2, so it would be 1.17%, which isn't very much. That's basically like having a savings account at the bank. And that actually is probably high for a savings account at the bank. So in 12 years, you'd only make $450, which isn't very much. Okay, so let's look at some population problems. This is the population of a town is decreasing. That is key right there, decreasing. That means we're going to use a decay model. So it's going to be P parentheses 1 minus R raised to the T. And it says we're going to decrease at a rate of 3% per year. In 2000, there were 1,700 people. Write an exponential decay function to model the situation and find the population in 2020 or 2012. So we don't know the ending amount, but we do know the starting amount, 1,700 people, parentheses 1 minus R, but remember I have to move the decimal place 2 spots. 1, 2. In 2000, that was this many. How many was there in 2012? That would be 12 years later. So it'd be to the 12th power. And again, I need the calculator. And again, all I'm going to do is I'm going to type in what's on the right side of the equation. So it's going to be 1700 parentheses 1 minus 0.03 close parentheses raised to the 12th power. Hit enter, and you get 1,179.53 or 1,179. Okay. So A would equal 1,179. And the reason that I would round to that is because we're looking at population. We're looking at people. We can't have half of a person. So we would just do 1,179. Okay. So now we're going to talk about compound interest. Okay. Compound interest, there will be a keyword. It'll say compounded quarterly, monthly, daily, something like that. So what you do is you have quarterly. Notice in here, everything about this equation is the exact same as the growth equation. The difference is the rate is divided by n, and the n is multiplied by t. N is how many times you compound it per year. Okay, so notice right here, n represents the number of times compounded per year. So if it's quarterly, that means it's done 4 times a year. So notice there's a 4 right there and there's a 4 right there. If it's monthly, that's 12 times a year. Right there and right there. Weekly is 52 times a year. If it was daily, it would be 365. If it was, if it was bi-weekly, some people will say that is 2 times a week. Sometimes people will say that's every 2 weeks. So you just have to clarify what that means. So if it says compounded, then we're going to use compound interest, which is P parentheses 1 over R, or 1 plus R over N raised to the NT. And then here's some generic ones, or some ones that are already kind of set up for you. This is an account that has a 6.35 interest rate, is opened with a principal of $2,641. How much money will you have if it is compounded yearly? Okay, so there's compounded yearly, compounded quarterly, and compounded daily. So we have to set up each one of those. So the basic formula is A equals P parentheses 1 plus R over N raised to the NT. So A is the ending amount, P is the principal, R is the rate, T is the time, just like in the growth formula. N is the only thing new. It's how many times you're going to do it each year. So this is going to look like this. A equals 2,641, parentheses, 1 plus R. My interest rate is 0.0635. I take this interest rate and I move the decimal 1 2 places. Over yearly. How many times am I going to do this each year? Once. Raised to the 1 times T. And then you use your calculator. Okay? So I'm going to grab the calculator and I'm going to type that right side in. 2,641 parentheses 1 plus 0.0635 close parentheses raised to the 5, because that's how many years? That would be $3,592.98 or 99 cents. $3,592.99. Okay, then we would do quarterly. So if we do quarterly, everything looks basically the exact same, except the N changes. 0.0635 over quarterly would be 4 times a year. A quarter is 4 would make $1, and then it'd be 4 times 5. And then you type that into the equation, and you type that into your calculator. So it'd be 2,641 parentheses 1 plus 0.0635 close raised to the 4 times 5. Make sure you put that exponent in parentheses, and I did not do that. And you want to put it in parentheses so the calculator knows that that both of those are the exponent, or you could just do to the 20th power. 4 times 5 is 20. and you get 9,000. That doesn't seem right, but 261 plus raised to the 2641 parentheses 1 plus 0.0635 close parentheses raised to the 20th $9,000. It says 9,000. That doesn't seem right. Oh, I know. I forgot to divide. Duh. So it's 2641 parentheses 1 plus 0.0635 divided by 4. I forgot to do the divided by 4. You got to make sure you divide your interest rate by 4 raised to the 20th power. I was like, that's way too high. $3,618. So this time it would be $3,618. So $3,618 and some change. Okay, and that is because you're compounding it more often. And then if you do daily, you would change the 4 to 365. Okay, it says a handheld organizer sells for $89. If the price decreases by 6% per year, how much will it cost after 5 years? That would be a decay model. A equals P parentheses 1 minus R raised to the T. Plug your numbers in. $89 parentheses 1 minus 0.06 raised to the 5. Plug it into your calculator and see what happens. So let's plug it into the calculator and see what happens. 89 parentheses 1 minus 0.06 close parentheses raised to the 5th power, and it would be worth $65.32. So it'd be worth $65.32 after 5 years. And it's just plugging the numbers into the formula and seeing what happens. It says a furniture store is closing out its business each week. The owner lowers the price 25%. After how many weeks will the sales price be moved from $500 to $100? Set up an equation but don't solve. So it would be, again, price is decreasing. So it starts at $500, but it's going to end at $100. So we use this formula up here. 100 is what we want to end at, 500 is what we start at, and it's going to be 1 minus 0.25 raised to the t. And again, we don't know how to solve for t yet. We will, but that's just set it up, but don't solve it, and then you're good to go. Okay, the last slide for this video. Continuously compounded interest means that your principal is constantly earning interest, and the interest keeps earning on the interest earned. So compound interest usually is not going to deal with money. We will have some examples that deal with money. Where compound interest or compounded actually usually happens is in nature, with reproduction and like things like that. So it says example 9. So let's go to example 10. It says find the amount of an account that starts with 600 and is continuously compounded for 8 years at a 12% interest rate. So compound continuous is A equals PE raised to the RT. And notice up here, the number E is 2.71828. There's a button on your calculator that you can hit that will give you E. So you just plug the numbers in. A is the ending amount, which we don't know. P is the starting amount, which is $600. E is just a number raised to the interest rate, which is 0.12. Again, it's a decimal. And then T is time, which is 8 years. So again, what you do is you use your calculator. So you do 600. And then there is an E above the division sign. So you hit second E, and that's second division sign. And then you raise it and make sure you put your exponent in parentheses, which my exponent is 0.12, which is the percentage, times 8. And if you hit enter, you're going to get 1,567.08 or 02, excuse me. So you get 1,567.02 if you round to 2 decimal places. Is how much money you would have after that 8 years. Okay?